Chapter 4, Lesson 2 of Pre-Calculus, and we want to wrap this lesson up by looking at two types of problems that we'll have to do applicationally with trigonometric functions. The first one we want to look at is what we call solving the triangle. And a triangle, you know, has 6 parts, has 3 sides and 3 angles. Solving the triangle means we want you to determine the lengths of all of the sides and the measure of all of the angles given just a minimal amount of information. In this case, given that the hypotenuse is 8 and one of the acute angles is 37. And this is something that we'll do continually as we work through trigonometry. It's something that we're going to really focus on, because if we can do that with triangles in just a general sort of way, we can then apply that methodology to real life by superimposing triangles in certain real-world situations to determine, lengths of or heights of buildings or lengths of, rivers or something like that. So being able to do this generally with just triangles is very helpful then when we go to apply it. So we'll do one problem here where we look at solving the triangle, and then we'll apply it to a real life situation where we do the same thing, only we're applying it to finding the length or the height of something in real life. So to solve the triangle, we're given the information that the hypotenuse is 8 and that one of the angles is 37. So we'll label the hypotenuse here as 8, and we'll label one of the angles here as 37. Now it really doesn't matter which one you use. You could use this one or this one. You're going to determine the lengths of all of them anyways, or the measure of all of them anyway. Now, let's figure out the angle first. That's probably the easiest. We know that all 3 angles in a triangle add up to 180. We also know that this one angle is 90 degrees because it's a right angle. So if that one's 90, that leaves 90 degrees to split up between these last two. So given that information, then I know that let's call this theta because we don't know what it is. So we know then that this angle theta plus 37 is going to equal 90, because these two equal 90 plus the 90 is equal to 180. So we solve this for theta, and so theta is going to be 53. So we now know that the measure of this angle is 53, and so we now know the measure of all the angles. Now we need to use trigonometry to determine the lengths of the sides. Now we can't use Pythagorean theorem here because the Pythagorean theorem requires that I know 2 of the 3 lengths, and in this case I only know 1. However, I do know my trigonometric ratios are ratios of sides in the triangle. Sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. So knowing that, let's say I want to figure out what the length of this side here is. Well, this, if I'm looking at angle 53, this is the side that's adjacent to it. That's what I don't know. And the one I do know is the hypotenuse. Well, adjacent and hypotenuse is the cosine ratio. So I could use that to my advantage, and I could say, well, the cosine of this 53-degree angle is equal to the side that's adjacent to it, which in this case is x, over the hypotenuse 8. And what I've done is I've created this equation with one variable, and so I can solve it algebraically. So multiplying both sides by 8, I have 8 times the cosine of 53 is going to be x. That's going to be the length of this. Now I could have also chosen 37. So let's say I decided to use this angle instead of the 53. Well, in that case, the x is opposite the angle, and what I do know is the hypotenuse, and the opposite over hypotenuse is the sine. So I could have used the sine of 37 is equal to the opposite side over the hypotenuse, and again I have an equation and then I can solve it. So 8 times the sine of 37 will also give me the length of 8. Now you might be asking, well, how can I use sine for one and cosine for the other and still come up with the same answer? You remember when we talked about these that with the 45-45-90s and the 30-60 90s particularly, that the sine of the 30 was the same as the cosine of the 60 of the other angle, or the cosine of the 30 was equal to the sine of the 60. So those are the same, will give us the same value even though we're using different angle. To further prove that, let's just go ahead and calculate both of these. So if we calculate those, you'll notice here I have 8 times the cosine of 53 gives me 4.81452, and 8 times the sine of 37 gives me the exact same value. It really doesn't matter which one of the two angles that you use, as long as you write the correct ratio and solve it correctly, you're going to get the same answer. So again, this would be my exact answer. My estimated answer would be the 4 point whatever we got when we just had that. So that would give me the value of this. Well, now I need to figure out the value of this side too, or the length of this side. And again, I use the same methodology. I can either use the 53-degree angle, and if I'm going to use that, that's opposite and hypotenuse, so I would use sine. So I could use the sine of 53 would equal the y value over the hypotenuse, and then solve it for y. And in doing so, I've now calculated all of the lengths of the sides, and I've also calculated all of the angles, and thus I've solved the triangle. Okay, so again, a very important exercise to be able to do. Let's take a look now at how we can apply this to a real world type situation, let's say. One very common application then would be to use trigonometry to determine the height of a building. So it says from 340 feet from the base of the building and an angle of elevation of 65 degrees, what would be the height of the building? So what we can do is we can take our right triangle that we just figured out and we place it up against this building. And we're 340 feet from the base. So if I'm standing right here, I'm 340 feet from the base of the building. Okay, and it says the angle of elevation is 65, and you remember the angle of elevation would be from a point looking up with a horizontal, so this would be 65 degrees. Well, what I have here is a right triangle, and I want to figure out the height. Well, I can use my trigonometry now to determine that, because I know an angle and I know one side, and I should be able to solve the triangle, so to speak, to determine the length of this one side. So if I'm using the 65-degree angle, the side that I want to know, the height, is opposite, and the side that I do know is adjacent. So which ratio is that? Well, that's the tangent ratio. So we can use that ratio. The tangent of a 65-degree angle is equal to the opposite side, which is in this case the height, over the adjacent side, which is 340. I simply now have that trigonometric equation. Whoops, why do I keep doing that to myself? The trigonometric equation that I simply solve. So multiplying both sides by 340. So 340 times the tangent of 65 is going to give me the height of the building. So we'll go ahead and calculate that. So we need 340 times the tangent of a 65-degree angle, and that's going to give me 729.13 feet high. So the height of this building is about 739 feet. Let's see, let's do that right. We don't know it's exactly, but it is about 739 feet. So you can see how being able to solve a triangle just in a general way, we can then superimpose a triangle into a real life situation and then determine the lengths or heights of other things. Okay? So that'll wrap up lesson 4.2, and we'll do your homework, and then we'll get some more applications of trigonometry as we go forward.